let's do a quick review video on how we describe quantitative data sets. So to start, we could be given a data set that looks like a histogram, a dot plot, a box plot. And in these questions, you're going to be asked to describe the distribution. So in this particular problem, we have a histogram showing the distribution of percents of women aged 15 and over who have never married in each of the 50 states and Washington, D.C. Anytime we're asked to describe a distribution, we want to use the acronym SOX for shape, outliers, center, and spread. So for this problem, we would write something like this. The distribution of women who have never married in each of the 50 states is skewed right. That's our shape. With a high outlier around 50%, that's addressing this unusual feature right there. So we have shape, we have outliers. The center of the distribution is approximately 26%. That looks like it's about the median, right about here. And the range is about 32%. Okay, remember range is a single number. So we're subtracting 52 minus 20. And for all of these, I'm writing approximately or about to note that it's not going to be exactly that. We don't know exactly what the lowest is. We don't know exactly what the highest is. It's somewhere between 50 and up to, but not including 52. Because remember, 52 would start, and that next bar is empty. Now, if we're given a scatter plot, we'd be asked to describe the association. Here we have a random sample of AP Stats teachers asked to report the age and mileage of their vehicles. And anytime we're asked to describe the association of a scatter plot, we want to use FUDs, form, unusual features, direction, and strength. The relationship between age and years and mileage of AP Stats teachers' vehicles is linear, that's our form. Positive, that's our direction. Strong is our strength. And no unusual features. Now, I would expect some of you guys to identify this as an unusual feature, and that's fine. You wouldn't be marked wrong for it. But really, when it comes to unusual features, if nothing immediately jumps out at you as, whoa, that point looks weird, we don't have to include it. And then just one note on these types of problems. Occasionally, instead of being asked to describe a distribution, we'd be asked to compare two distributions. So in this problem, we have salary distributions for the Yankees and Phillies back in 2008. And anytime we're asked to compare the distributions, we need to make sure that we use comparative language, noting what things are the same, what's different, what's bigger, what's less than, etc. So for this, we could say that both of these distributions are skewed to the right. That's noting that that's a component that's the same. Though the Yankees distribution has a stronger skew with at least one high outlier around 32 million. The spread and center for the Yankees is higher than for the Phillies. Okay, and the center, I used the median. If I counted up all the values in here, I found this at the 26. All right, same for about this. And I counted to the 13th value, 13th and 14th, average them. So that gave me the median. Range, again, is a single number.